So, hello. I'm here to talk about how to turn massive amounts of stream data into real-time personalized experiences for millions of users. Just quickly about me, my name is Darryl Kanouse. I am the Senior Director of Consumer Technology at Activision. Before that, I was Principal Solution Architect at a marketing agency called Rosetta. Activision was our client at that time, so I've been with Activision for a couple years, but worked with them for about 4 or 5 years. My specialty is in large-scale user engagement technologies. And at Activision, I lead the group that's responsible for the design and development, deployment, support, and management of the platform that we use for personalization and commercial technologies. I also do wire art and music, and I have kids that I love, and this is my wire art, and I have to put it up because I do one of them every day. Today's day 181, and that was the one that I did. If you're like me and you Google your presenters, you'll see a lot of this stuff. But anyway, so let's talk about the massive amounts of stream data for real-time personalized experiences. I have sort of the subtitle of Architect for Success. I think it's probably a bit of a cliche to say that, but that's definitely my perspective. There's a lot of things you can do with optimizations, low-level tuning, that kind of thing, but the decisions that you make up front about how you're going to build your system tend to be the ones that are going to determine your success or failure in these kind of scenarios. So we'll talk a little bit about how at Activision we went about the process of architecting our solution for streaming data and the role that Cassandra plays in it, obviously. So the main question that we ask ourselves whenever we're making any decisions about how we're going to design stuff is, will it scale? And that's something that when you talk about Activision and the titles that we have, our user base, scaling is probably the thing that we spend almost all of our time on, making sure that our systems can support the types of data that comes in at the volumes that it comes in. There's some important things to think about when you're talking architecture. There are technical considerations, and then there are non-technical considerations. I think the non-technical considerations are almost as important as the technical ones. Technical ones you can do something about. Generally speaking, the non-technical ones you cannot do anything about, and they sort of define the constraints around the system that you're trying to build. So we're talking about stuff like business timelines. A company like Activision, we release video games on an annual cycle. November is the big release month for us. Whatever solution we come up with and however we architect things, they need to fit within the constraints of the business timelines. We can't have our solution deployed in December. That just doesn't work. And I'm sure in most other businesses, there's a similar type of constraint around product releases and how that stuff works. There's also the financial environment that you're working within. Again, this is oftentimes stuff that we don't have a lot of control over. It's budgets. I think that's pretty normal. I think we're all sort of familiar with that. If we had an infinite amount of money, our solutions probably look a lot different than they do with the reality of the budgetary constraints we have. Also, legacy systems, something else we consider a lot of. When we are talking about taking a personalization platform and adding it to a video game, we're talking about bringing a new system into a pre-existing ecosystem of a bunch of other applications. Understanding what they do and how they work is important in helping us decide what decisions we're going to make and how we're going to approach our solution. And then finally, there's organizational politics. I'm sure everybody is familiar to some level of that. Activision, it's not really that bad. In itself, organizational politics is neither good nor bad, but sometimes you'll run into like, why did they do that kind of questions that are only answerable because somebody said so. But that helps also to kind of constrain a little bit about how we think about our solutions. So I guess that's all to say that when we talk about how we're going to do things like large-scale personalization and real-time stuff, the context under which we're building this application is very important. So with respect to Activision and the context there, let's just talk a little bit about the history of Activision and kind of how we got to the things we're doing this year. I don't know how many of you guys are familiar with the company. We started in 1979. We were the first third-party developer for indie games at all. And it was for the Atari console cartridge system. Up until Activision got started, all of the game titles that you got were made by the manufacturers of the consoles. So that's a legacy that sort of continues on today. We are still the largest third-party game developer. As far as the industry as a whole, just to kind of give you a sense of when we talk about large scale, Activision is a big player in this industry, and this industry is very, very big. 155 million Americans play video games. 51% of all US households own a dedicated console, whether it's an Xbox or a PlayStation. 42% of Americans play more than 3 hours. Over $22 billion spent on the video game industry. It's big, and Activision is one of the biggest players in that industry. We currently have over 4,000 employees. We've got 38 locations. That's kind of a mix of offices and development studios, support teams. It kind of depends on the day that you're asking. That tends to be in flux, but that's about where we stand today. We release a lot of video games, a lot. But there's 3 that at the moment are probably the ones that most people have heard of. They are our blockbusters. They're the kind of tentpole titles in the organization. Call of Duty, you probably have heard of that one. Destiny was released last year, one of the biggest new IP releases ever in the video game world, which is not hard to do. These new records can be broken often because the video game industry is just growing so big and so fast that new biggest releases happen kind of all the time. And then Skylanders. If you guys have kids, hopefully you're familiar with Skylanders. My kids have it. I step on the little toys all the time at home, but it's a lot of fun. So that's kind of our business, more or less. And when we talk about personalized experiences within that context, we sort of start with the general belief that personalized experiences are better than experiences that are not personalized. I don't think that's very controversial. I'm sure there's lots of statistics that can support that, but I think at this point we all sort of acknowledge that that's the expectation users have, personalized experiences. That's the thing. But we don't just do personalized experiences for nothing. Obviously, the reason why they're valuable is because they increase player engagement, they make people happy. And in the video game world, for us, we can measure that engagement through a couple of key metrics: session frequency and duration, basically getting people to play more, presumably because they're having a good time and they're enjoying it. And also, we are a business, so the average revenue per user is a metric that we also look at. Just as a side note, the acronym for average revenue per user is ARPU, which still elicits giggles when we talk about it. There is another metric that we look at, which is average revenue per paying user, which has the unfortunate RPPU acronym, but people still giggle when we talk about it in the office. But those are the things that we look at, and that's how we know that we're successful in our personalization efforts, because we're seeing an uplift in these kind of metrics. Historically, we've done personalization across a lot of channels. Started with email, we do website stuff, mobile app has personalization. Most of what we'll talk about architecturally is the in-game on-console stuff, but I think it's important to understand that the platform that we built is multi-channel and supports a lot of different stuff. So some background on those channels and how we got it from a development team standpoint to where we are today. That's kind of the story of CRM. And if you guys are familiar with CRM as a traditional discipline, customer relationship management, outreach, that's the type of an organization you would expect would be responsible for personalized experiences and driving engagement and making people be repeat customers. And at Activision, about 5 years ago, there was the beginnings of the CRM group that has now evolved into the group that I'm a part of today. And at that time, this was 2011, with Modern Warfare 3 was kind of the start of Activision getting into data as a source of personalized experiences, and it's something that we can look at to get insights from our customers, not just to do reporting for financials, but to actually impact the game experience. At that time, it was very basic. We're just doing basic segmentation strategies like, do you play a lot or do you play a little? Are you good with your KD or are you bad? And then we would send you emails that are related to that. But it was kind of putting our toe in the water. Technologies we used at that time: Hadoop for all the basic data collection, InfoBright, Oracle. Oracle was kind of a legacy system that our IT group had, but we used it. We had Eloqua was the email service provider that would actually send out the emails. And we had a lot of guys who would write SQL code against Oracle to produce CSV outputs that we would FTP off to an email service provider to deliver emails. And that's where we started, and those were the days. So now, moving on to the next year, Black Ops 2, it became important, we realized, to stabilize the data environment. This was the first time we'd actually looked at millions of users' data all coming in at the same time and trying to deal with it. Now, at this point, we're still not talking real time. We're talking about capturing the data and analyzing it offline. Automation clearly was becoming a problem. Having people writing SQL code is not an ideal scenario to generate ad hoc lists to send emails. So it was the beginning of an automation process. And we refined our targeting so that we weren't using the same basic segmentation around are you good or not, but we actually started to look at stuff like, well, what are you good at? And maybe that's something that we could use to talk to you. Are you really good at a particular mode of play versus some other mode? Our technology platforms evolved only really to the extent that we ditched Oracle, not a year too soon. And we used InfoBright as the basic data mart for all of the data points we were using to drive the personalization. ExactTarget became a new email service provider, and we went to J2EE, Java-based application to do the advanced targeting and automation stuff. So moving on to 2013, we learned a lot of stuff from the previous year. One of them was that InfoBright was terrible. I hope there's somebody from InfoBright here, but it did not work for us. We had lots of problems keeping it up. But what we did want to do is continue on the path of advancing our segmentation and advancing the personalization efforts by looking at more and more data. And then we also began to introduce some of these other technologies, increase the automation. This is a progressive step along the path where we had been before, basically just getting better at email. But we got a lot better at it, and we saw a lot of great results through this effort. Encouraged the organization to kind of move on to where we're at now. So one of the key things that happened this year was, in 2013, was the development of a personalization engine that, as a modular component, was the type of thing that we could throw data at, throw a set of rules and some content at, and it could smash it all together and produce an experience. That experience was email at the time, but even now we use still the same basic principles in how we do the stuff in-game. Our mandates for personalization, now we're starting to see some hints at how our architecture is going to need to conform to some of the constraints. We have to maximize relevance and user value. We can't just talk to people about nothing. We can't put in front of them suggestions that they buy stuff that they're not interested in. We really need to make sure that people feel there's a value add by this personalization effort. We need to optimize for performance. We're seeing lots and lots of data. Still, you can always kind of improve in that area. And then the last part was providing controls for administrators to be able to dial up and dial down certain pieces of content as they saw marketing strategies that could benefit from that type of thing. And this is kind of what it looked like. This is email form, and I think this is a good representation, more or less, of the general approach to personalization that we have still today, even in the game. And I think one of the things that sort of is worth looking at, oh, look, I got my little pointer yesterday, and it works. So if you compare the guy over here on the left to the guy over there on the right, you can see that the way we've stacked content is different. As a rules process, there are perhaps stats we want to give to people. There are achievements we want to congratulate them about. And obviously those things are going to have some degree of customization. They'll have the relevant data points. But the question for us is, do we show them stats at all? So if you look at the person over here on the left, that guy would be somebody we might consider to be a noob. And we would say, for him, he had a good week, let's show him some stats. He might get kind of geeked out on that and think that's great. The guy over there on the right, perhaps a vet, perhaps not as impressed with his own stats, however, would like to know that he prestige because he spent a lot of time playing the game. So these are the types of ways that we kind of manifest experiences, and this is a good visual for how that works. It all kind of starts with having a lot of content. The kind of personalization that we talk about doesn't really work if you only have 3 or 4 things to talk about. We actually have thousands, I think 10,000 by last count, of individual types of things that we can talk to people. So as you can imagine, there's a pretty massive production machine behind all this stuff that generates this content. But anyway, this is sort of my thud factor thing. But you can see some of the types of things we're talking about: stats, congratulating people, giving them tips, all sort of geared towards making them feel good and want to play more. Okay, so last year was 2014. This was the big shift from out of the emails and into the game. This is I can't really overstate what a significant evolutionary step this was for us, because it meant now that our systems had to be production ready. It's one thing when you have stuff that's working offline and you're writing applications that maybe send an email, maybe don't. But when you're talking about putting something in the game at Activision, you need to tread very carefully. And this was the year, and not too uncoincidentally, this was the year that Cassandra came into play for us, where we started to realize that in-game, you're talking about communicating with everybody. In email, you've really only got a small subset. You're also talking about the need for reliability, the need for performance. Everything starts to get a lot trickier. And so Cassandra, we still use Hadoop and Greenplum as an analytics source of sorts, but here came Cassandra. and we'll talk more about how that Cassandra stuff worked. This is what it looked like inside the game. Like I mentioned before, you can see a lot of the recurring themes. Here somebody got an achievement for something. There's a tip on how to use some of the score streaks. Again, these are all targeted specifically. I think these were mine. I think I used the missile very poorly, and so it was telling me how I could use it better. But you can start to see, and we got very positive feedback on this as well. So now we're talking about this year, and this is where the real-time piece came into play, and making it happen in real time. If getting in the game was an incremental step forward in terms of general stress and anxiety about the application, making it happen in real time is now really ratchets up the thing. You can see we have a slightly different technology stack that we're using now. You'll recognize that, I probably don't need to say it, Amazon is playing a role in what we're doing now. It wasn't before. But we still have Cassandra. And one thing I will note now that if you were noting on all of the slides, this is the first year that we actually stuck with a data platform for profile management, 2 years in a row, and it was Cassandra, and that's why we're here. It's great. It works out for us. Okay. So I think that's kind of the context for how the business got to the point where we're building the thing that we're building now, and to sort of understand how we think about the way the application is supposed to work. So this is the team size, more or less, that builds the thing that we're working on. There's a core nucleus of people that is maybe a little bit less than this 41, but 41 people probably on a day-to-day basis have some sort of interaction, whether it's working in the studio side in building the game client code to interact with personalization, or it's building the systems on our side to do the database, and there's also content managers, QA people. So this is the size of the group. Excuse me. Okay, so we have a thing that we want to build, personalization, streaming, real time, and we need to put it into the game environment. We are putting it into a very, very noisy place that has a lot of stuff that's happening in order to keep a game like Call of Duty active and online. There are systems and services that are constantly running that we need to be aware of so that we don't sort of step on them. This is a bit of the legacy system consideration. Authentication, matchmaking, marketplace, these are all critical game services that need to always be online to make the game work, and we are bringing ourselves into that ecosystem to support that. So what the ecosystem looks like, game clients. So here's 3, but it's really more like 30 million, but more than 1, I guess, is the point I'm trying to make here. And they talk to a service gateway. We have peak concurrent users that are somewhere around 2 to 3 million, give or take, depending on whether a game just launched or whether it's April. And we have a service gateway that acts as kind of a proxy and a caching tier between all the back-end services and everything that the game and all the games and the way that they interact. So all games talk to the gateway. Behind the gateway is a whole set of services. I don't think this is a particularly unique or different kind of architecture. I think you'll see this in a lot of places. And this is sort of how it works. Also, just like in a lot of other places, the mess is behind the service tier, where you have a complete hodgepodge of a bunch of different things that have developed like barnacles over the years that are core applications that need to run but that haven't been touched in a long time, and they're all kind of mix and match. But the truth is there's actually some rhyme or reason about that. There are owners of the systems, and they can tell you why they are the way they are and how they need to be there, and as it happens, we are basically building one of those things. We're another one of the tentacled, barnacled bits that are in there. Okay, so will it scale is the question about our application. So ensuring that it will, making sure that the answer can be yes, is where we start looking at the requirements in a little bit more depth. And one of those is to understand what personalization means. So for us, I think it's important to lay out up front what personalization is not in a game like Call of Duty or any of the games we do, and it is not messing with progression systems or changing weapon performance on a personal basis or monkeying with maps or any of that kind of stuff. And as much as we would like to make the game easier for people who are bad because we know they will play more, that sort of violates the notion of the integrity of the game and the level playing field that we need to support. However, we do have a lot of options of things we can talk about that will result in people having a better time and getting better and enjoying it. And I don't know how many of you guys play Call of Duty. I know my first experience of it was brutal, it was terrible, and it was frustrating. But after many hours of play and lots of tips, I feel like I'm a little bit better now. And mainly it's kind of like tips and congratulatory attaboy type of stuff is the thing that kind of keeps people coming back, despite the fact that it can be a relatively brutal experience. So the other thing to consider, that's what personalization kind of is. It's sort of the in-game manifestation of stuff that we talked about in email. Then there's also the consideration of what does real-time actually mean. And there is nothing that is instant in anything in the world. There's the speed of light constraint. But in addition to that, there's also, you got to move data from one place to another. You've got to act on it, and you've got to get back. So really what we're talking about when we try to define real time, we're talking about what is an acceptable amount of latency between a behavior that we see in the game and a resulting targeted communication that comes out of that. So the window that we have to work with is what happens there's the end of the match when you're playing a game. There's data that gets packaged up and it gets sent off, and that starts the clock ticking. After that, if you're playing the game from a user experience standpoint, there's a kill cam. It's a sort of a replay of the last guy who killed somebody, and it's fun if you're that guy, not as fun if you're the guy that got killed. Then there's an after action report in the game. That's a kind of a list of stats, and all this stuff is happening in the game while we are taking that data in, processing it, and trying to decide what we're going to do next when they drop back into a lobby. The lobby is kind of like the waiting ground where people sort of sit and wait for the next match to start, and that's really where we want to take the most advantage of an opportunity to communicate to them. That's when most people who stop playing while they're sitting in a lobby. So we'd like to do it in under a second to get all the data out of the games and to get it back. And we can do that when there's only 2 or 3 people playing. When there's 2 or 3 million people playing, it's a little bit harder to do. So we have to measure what is too long for us to wait. And for us, it's 29 seconds. So that 29 seconds may seem like a long time away from real time, but in any system like this, when you talk about real time, you're measuring it by the experience of the user. And in essence, the experience will feel real time because they played a match. The first opportunity we had to talk to them, we have something that's relevant and related to that data. So what needs to happen in that 29 seconds, and really 29 seconds is definitely the high water mark or the backstop. If it takes more than that, we just won't do it, and we really can do much better than that. But here's all the things that kind of need to happen. Parsing the inbound match stats, determine whether or not the profile update needs to happen, archive the inbound data for analysis and for replay, deliver the user to the business engine, the rules engine that can assign the content, and that rules engine will then load the user profile, including all the stuff that is generated offline, apply the updated segmentation, determine appropriate messaging treatment, and a bunch of other stuff, and then eventually send all that stuff back out to the engine, back out to the game. And doing that for peak concurrent volumes, that's really what our challenge is. And when the question is, well, will it scale? Is whatever you can do to make this happen something that you can do when there's 2 or 3 million people that are trying to do the same thing? So the answer is yes. And we can do that through 3 core architectural principles. The first one being a low latency, high volume data store. I don't think there's any mystery what that is. Stateless bespoke processing nodes, we can talk a little bit about that. And then queuing, a lot of queuing. Total side note, queuing is an 8-letter word with 5 vowels in a row. It's the only one in the English language. I take an opportunity to write it, so there it is. So first, let's talk about the low latency, high volume data store. I think it's pretty self-evident that the more you know about somebody, the better you can be at communicating with them. And so let's just say, hypothetically, what we want to do is recommend or talk to somebody about a particular treat, a cupcake, for example. Knowing a little bit about them, we can understand that in this case, they like frosting. What we're talking about from a game standpoint is just understanding what console do you play on, how long have you played, what's your XP, what level are you at, and that can kind of provide some constraints around what we would tell you. The more we know, I think is pretty obvious, the more refined we can get in what we're trying to talk to people about. So eventually you get to a point where you got something that looks really personal, and that's really what we're trying to get at. The balance is that in order to do that, you need lots and lots of attributes, lots of things to know about a player. At this point right now, there are 1,000 attributes that we are tracking for every individual. And this is only the stuff that we've decided to retain as useful in their profiles, which are a snapshot of their current state. This is not representative of all of the data that we capture, the match level stuff for the purposes of analysis and replay. This is really only a profile for an individual. So when you're talking about 30 million users and you've got 1,000 attributes, you're talking about a profile store of sorts that's going to need to have 30 billion records. So one of the things that is sort of important when we try to understand how we're going to deal with this volume and how we're going to scale is try to be judicious about where we get the data and what are the things that really have to be real time versus the things that don't have to be real time. Because the fact is, there's a lot of stuff that really doesn't have to be real time in order to provide the right experience. So we look at our data sources. The real-time data source, that stream that comes in off the gateway that everybody is playing, provides us with this kind of stuff: session start, equipment setup, what weapons and things you choose when you start a match, the match summary data, which is a critical piece of the actual metrics for an individual, clickstream stuff, marketplace bits. And contained within that real-time stream is the source data for everything else that we're trying to do. In addition to that, there are the things like, hey, somebody just got 100 kills in a match. That's awesome. We need to talk to them about that. That is a real-time trigger. We need to do something about that right then. But there's other stuff that does not happen in that same sort of time frame. Churn propensity models, anything that is sort of model-oriented, that is a trending analysis, those things don't tend to change match by match. And so we don't actually have the same requirement to retain that stuff in real time or to act on it. So those are the two bits. We're going to have to take those two parts, and we're going to have to smash them into a profile that we can access very quickly. As a database design principle that sort of informed how we set up our Cassandra instance, we took the notion of decoupling and design schema from the business model, which is not an unusual approach when you're talking about NoSQL databases versus relational databases. For some people, it is a shift in how they do things. They hear requirements about, like, say, for example, you're talking about a video game. You have things like maps, you have things like weapons, and you have users. So you would have a maps table, and then a users table, and then a user maps table that would have your stats about that. And you have a lot of joins and stuff that you all have to assemble this master profile. Rather, what you could do is just call anything that's an attribute a thing, give it like an ID, and say, this represents your kills in domination on the map called Turbine, and so on. And so you can just stack all those together. And what that does is it creates flexibility for adding new attributes. So things can happen in the game. We can track them, and we can put them into our infrastructure without the need to change anything in our data model. It gives us consistency on the interfaces with the data access layer. So how we access the profiles doesn't have to change. There's no new SQL queries. There's no any of that kind of work to do. We're basically just striping out a ton of attributes based on a user ID. And it optimizes the select operations. This is essentially the case for NoSQL databases, more or less. The flexibility, the ability to just kind of dump things in and do what you want with them. So what you end up with is a user profile that might look something like this, where you have the user ID and then a bunch of rows, if you will, that are the attributes, and then some value that corresponds to those. In a real-time scenario, we have to evaluate, which of these things are necessary from a real-time perspective, and which of these things can we load into the profile offline. This kind of defines the right profile. I think in our case, it's probably no surprise that there are, our writes outnumber our reads by probably 10 to 1. Our reads are stripes of full line data for an individual user. Our access to the profiles has one query type, and one query type only is, give me all the attributes for a particular user. Our writes are obviously a lot more complicated. And this is why we're here, because this is why, in our minds, Cassandra was the only thing that has really worked for us to be able to handle the volume of this balance of reads and writes. Like I said earlier, I come from the perspective of architecture. There are certainly optimizations that make this stuff go faster. There's always adding more nodes, that kind of stuff. But essentially, you're talking about a data schema that is going to support it in other situations wouldn't. So this is an example of what an actual schema would look like. So if previously was sort of an oversimplification, in the real sort of business case, our player fact table. So we use sort of legacy terms of fact and dimension relationships from Warehouse. This is a representation of the kind of legacy and the context that we came from, where warehousing was the thing. So we've still adopted the same naming convention, although if you think of fact and dimension tables in a traditional warehousing way, that is not at all the way we actually store data in Cassandra. But it is representative of the fact that basically all we're storing is integers of some type or another, because the applications don't really need to know specifically what it is, because they're all sort of the same. And we have a partition key of user ID and network ID because this is the only way we ever access profiles. Our reads are very, very simple. We have the cluster key that represents what the actual attribute is in itself. That's going to provide us with a level of uniqueness and distinction around each of those things, which lets us do kind of cheating and shortcuts around just kind of upserting whatever comes in. It gives our application developers a lot of leeway and is sort of forgiving. And all that they're really updating is these little bits of values that we then will assemble and marry up with some set of rules. We keep track of the dates, if there's a change in the value, what that is. Yes, so, and then there's the value itself. So that was the low latency, high volume data store. It's Cassandra, and it's awesome. Stateless bespoke processing nodes. I'll just try to talk about this stuff quickly because I know I'm already running low on time. In a traditional architecture, or I don't know if it's traditional or not, but this is the way you see this a lot, a standalone application model. We are building a thing, and the thing has an application code base, and we have a lot of shared modules, and it kind of runs together. You can sequence all the things that are supposed to happen in 29 seconds in one continuous procedural set of code. But the problem there is that you don't have isolated scaling controls. So when you have performance impacts that are, say, the result of too much data coming in, you can scale horizontally, yes, but the efficiency on resource usage is you're now extending your rules engine across all those additional nodes, and you're not really maximizing the opportunity to separate those stuff out. The bottom line being that the impact of load isn't equal on all parts of the system. The things that might make the engine run slower are going to be stuff like seasonality, Christmas stuff. We want to talk more to people. Whereas like an event reader is going to be impacted by the number of concurrent users, which goes up and down. So these are the three basic parts of the application, the real-time processing bits. I think these would be a pretty standard delineation of how you would set this type of thing up. Inbound event streaming and the parsing of that, it is to some extent kind of contained. There's real-time rules execution, and then there's the offline data and messaging processing. So the architecture gets updated, and it looks kind of like this. Inbound event streaming reads off of the gateway and updates Cassandra and its profiles. There is the rules engine that now knows, hey, I've got a user and I've got to process this user, so I will read from the user profiles and I will update back into the gateway to get back out to the client. And then there's an offline data processing bit that is completely decoupled from the rest of the application, still doing core and important stuff like updating the profiles with all that offline stuff. So then just a quick, on the last point here, queues. This may go without saying, but we would have a very hard time scaling our infrastructure to support the maximum load. Because the peaks and valleys in the load that we see is extreme. What we see on November 7th, the day after a COD title gets launched, versus June 7th, after people have been playing it for 6 months, it's a magnitudes of 10 to 1. We can't support an infrastructure that can just look at spikes all the time, 100%. It's not really cost effective. And this is not even accounting for time of day, which has a huge impact on how data volumes come in. So use queues. Queues lets us set up an infrastructure and all these individual components in a way that they can have a little bit of wiggle room. So we can plan capacity around what we think is 95% of the spike, and let queues kind of squish in the rest, so that we don't lose any data, nothing gets overheated, and we don't end up spending a lot of money on having infrastructure that we don't really need to support. So when we add queues, the updated bit looks a little bit like this. Kinesis is what we're using to manage the inbound data stream. I think I mentioned earlier, we're in Amazon. Kafka is obviously is an alternative for Kinesis in this type of situation. Our highest data volumes is the stuff that comes in straight out of the games, pure, unadulterated. We can use Kinesis to start breaking that stuff up into categories and to give it the kind of springiness that lets us kind of queue through it. We're going to eat up some of our 29 seconds, but at least we're still going to be, we're not going to be losing any data. Nothing's going to get overheated, and we're not going to pay for massive infrastructure unnecessarily. The other part is RabbitMQ. So we want to isolate the dependencies on the inbound data with the actual rules processing, because they have different sets of concerns around when they get overheated and when they reach capacity. RabbitMQ is good for that, in part because while the data volume is massive that Kinesis needs to support, the data profile in Rabbit is very small. We're just sending in batches of user IDs without any of the other data, and we're letting the rules engine query Cassandra itself to figure out what needs to go there. So in the end, this is what our real-time streaming data processing for personalized communication architecture looks like. We have game clients that talk to a service gateway. The data that comes in off the game goes into Kinesis. We have an event parser that reads Kinesis and determines if there's anything valuable there. It archives the stuff into, I guess I didn't mention this part, this little, where's my little pointer? So imagine me pointing at S3 EMR Redshift. So into a warehouse that gets archived. We update our user profiles, and then the event reader hands off the set of users that we need to process into a Rabbit queue. The rules engine, reading the queue, says, hey, I've got a new set of users I need to process. I query Cassandra. I get new sets of profiles, all striped out attributes, ready to go, process some rules, marry some content, and send it back out to the service gateway to go back into the game. And this whole loop can happen because of the springiness, because we split the stuff out, and in no small part because we have Cassandra as a back end. We can do all this stuff really fast at really high volumes. And so, yay for us. So again, just sort of the review, the low latency, high volume data store, Cassandra. I could just replace that with Cassandra. I was talking to somebody earlier today about, they were asking me, so like, what are the benefits of Cassandra versus some of the other stuff that you had used with to try to do some of these bits? And I'd kind of given her some of the history. And I couldn't really think of a good answer to the question, like, what are the benefits Cassandra brings versus something else? Mostly because I couldn't think of anything else that we could have fit into this particular use case. So I don't know what the benefits, I don't know that there even is. I ended up telling her that the benefit is we could do it, and the alternative is we couldn't. So stateless flow processing nodes and queues, so we just talked about that. And then also maybe perhaps of some sort of interest, some of the other technologies we use, just to run down the list, Cassandra, obviously, Kanouse, we talked about, RabbitMQ, all the core application development, the rules engine, the event parser, that's all Python 2.7. We may move to 3 eventually when everybody else catches up. I think it's only been out for like 5 years or something. So we're sticking with 2.7 for now. S3 Redshift EMR, this was our Amazon replacement for Hadoop. Well, Hadoop still plays a role, but this is our analytics mart, which is suffice to say that. MySQL, I didn't mention this before, but it's worth noting that the rules engine itself does need to have some sort of configuration for how it runs. We use MySQL for that. It could be anything else, but we have a Django interface that connects to MySQL. The knobs that I talked about earlier in terms of implementing a strategy and setting up content, who to target, all that stuff happens in that way. We use Git, Copper for server monitoring, Ansible for infrastructure deployments. So I guess the last point to make here is we're in a good place. 2016 is coming up fast. With every new year, you can be sure there will be another Call of Duty title. There will be more Skylanders. There will be more of everything. And so what are we going to do? I mean, I don't know that we can continue this pace of innovation. Maybe we can predictively guess what your stats are going to be on the next game. I'm not really sure. But one thing I can say for sure, Cassandra is going to play a role in it. We're pretty well embedded. Our use case is so well coupled to what Cassandra does for us. It's hard to really imagine getting outside of that. So I think I have 2 minutes and 47 seconds left. So thank you. In 2 minutes, if there's questions, I can do it. And also, that's me and my wire stuff. Thank you.
Hi. Can I just see the previous technology stack one more time?
I'm sorry, you can dead.
I just want to take a look at the technology stack slide one more time. Thanks.
Sure, this one? Yes, that's good, fun stuff. I think of all the stuff that's listed here, I feel pretty confident about all of it. There's nothing, we're not really in the middle of any kind of reevaluation or anything. Oh, question, cool.
Can you say a little bit more about personalization and the rule engine?
Say more about personalization and the rules engine?
Yes.
Sure. I just, like at a high level, I think one of the things that sort of differentiates us from some of the other approaches to personalization is a notion of segmentation and event-driven mixing and matching. So there are lots of vendors that offer personalized solutions and stuff, but we have a kind of a brain trust from marketing agencies who've worked in this space for a long time that have kind of put this stuff together. It's a bit of secret sauce, but I think if you consider those emails that I was showing, it's really important to us that we add the extra dimension of not just a customization of a stat or a choice of a color or a user-defined type of personalization or even the right recommendation in the right spot, but the question of do we even show a recommendation at all? Do we even show stats at all? And what's the order in which we place those? And that to me, in all of my experience in general communications and CRM and marketing and all that feels like a big differentiator. And it's also is resource intense on the back end to process rules like that. So a large part of that 29 seconds is evaluating users against content and maxing out the matrix to make sure that you end up with an experience that works. Over there? Thank you. Or thank you.
The player profile and data fields or data products there you update in real time. Do you guys do any segmentation using this?
So yes, but the role that segmentation plays for us is slightly different than traditional segmentation. We don't do the segmentation in real time per se because most segmentation is trend based. So like we do churn analysis is important for us. Do we feel like someone's about to stop playing? And if so, we need to intervene, give them some encouragement and all that type of stuff. But we don't tend to find that stuff matters in real time. But the data that comes in real time still serves as the source data for those models and for that segmentation. And even within that, once we apply the segmentation for a user, there's not a one-to-one map between the segmentation and then the experience that we deliver to them in the personalized bit. There's a bunch of other sort of informing data points that we also use. So it gets very, very personal. Apparently I'm out of time, but I'm happy to take off the mic and we can talk. All right, thank you guys.